here the standard work measurement or time estimate. Idea here is primarily to establish the time for a job without actually conducting or doing the job, using the data which is available from the past record of the time studies or the data of the time developed using PMTS method. Okay, so procedurally how it is done, there are different steps, but how any job which is new, for which time is to be established, so how do we proceed for that? So say a new job or the new kind of a component to be made, so how to come up with the time required for that? So a new job is there, so obviously there will be little newer conditions with that which will be used for the manufacturing purpose or for producing that job, for doing that job. So the new job has to be understood very properly. So we need to understand and then analyze the job with regard to the like what are the different things which are need to be done for completing the job. Okay, so this analysis will be giving the idea of the presence of the different types of the like activities, or we can say elements that need to be done, need to be completed. So presence of different types of the activities, or in short in terms of like standard data method terms, different elements which are present in the job. Okay, and these elements need to be now seen for more and better clarity, like what these elements are or what type of these elements are. So we have seen earlier there can be setup element or simple continuous production type. So production element or setup element. Setup element is constant and the production element can change with the volume to be produced, number of units to be produced. This is one. Then element can be constant, like every time switch on, switch off, load on, hold or unhold the workpiece, put aside the finished job. So there can be a range of the activities, measure the diameter. So there can be various constant elements, means the elements which take almost the similar time. Okay, and the variable elements are those for which the time will change with certain characteristics related with the job to be produced, like the time to clean a particular floor will depend upon the area to be covered. Similarly, the length of time to turn a sample will depend upon the like the length of the job which is to be covered. So we'll talk little in detail about the variable elements. This is variable element. Okay, then these elements which need to be performed are also seen with regard to like whether it is occurring in every work cycle or it is irregular. So the one which is occurring in every work cycle is regular, otherwise it may occur at random or regular intervals, but not in every cycle, like after every 30 minutes, 30 cycles, or after 20 cycles, like say the tool replacement, once the tool is worn out, or like the entire rod of the job is to be replaced. So depending upon the kind of the work, certain activities or elements may be irregular, which may be performed at random intervals or at a regular interval, but not in every work cycle. Similarly, the elements also to be seen like the manual elements or it is machine element. Okay, then element is can be done in parallel with some other activities, then it is called internal element and external element. Okay, this is just for the clarity only. Otherwise, whatever is to be done, you will see whether it is whatever the element is, it will be either taking randomly some constant time with little variation, or the element will be changing with certain characteristics like this. So how to come up with the time values for those elements which need to be performed to complete the job. Say if the job is to be produced, say the batch of 30 is to be produced, then what we need, like setup is to be done once the tool setting or the programming is to be done just once. Then it is possible that we may require holding of the job every time. Okay, then after holding, machining will be needed. Then it is possible that just to verify that job has been machined properly, the measurement or the dimensional measurement is to be done. So this may also be done repeatedly in every cycle. Then unhold the job. Okay, so unhold the job. So if you see, these are the kind of steps which need to be done in production of the batches. So if you see, this is to be done just once. Okay, so this may be a regular element or of setup type. This is very regular element, but it may be taking constant time because all similar type of the jobs are to be mounted on the machine in the same fashion. So it will be taking, like say, holding constant time, and it is regular, constant element of the regular type. Okay, then there is a machining will depend upon the kind of the length of the job which is to be machined. Like the few are of 50 mm length, others are of 100 mm length, others are of 150 mm length, or few are of say 10 mm diameter hole is to be drilled, in others is 15 mm diameter of the hole is to be drilled. So depending upon the kind of the geometrical features or the length of the or the dimensions of the area to be covered, this time can change significantly. But since it will be integral part of the every work cycle, so this will be a regular element. Okay, but of the variable type, which will depend upon the kind of the dimensions or the area to be covered. Then measurement may also be a constant element, may be occurring in regular manner. This may also be constant, may be occurring in regular manner with each work cycle. So every element, whatever is to be done, has to be seen what are the factors that can affect the time associated with that. So like since setup is being done once, so it is a kind of it may be taking like say 30 minutes or 1 hour, but same setup will be used until the entire batch is produced. But in any way, this has to be counted because it will be consuming the labor hours or the worker hours. Similarly, for the labor or worker hours will also be considered in the, like say the holding, or but few will be happening in regular manner and few will be happening in irregular manner. Few will be constant with regard to the time that they will be taking, and few will be variable with the kind of characteristics of the job which is to be made. So we will see little more detail element. Each and every element has to be seen what are the different factors that can affect the time for each element. So that has to be considered. Factors affecting the time for each element has to be seen. So will not be just prejudiced that it will be a constant or variable. So let us see that how the time for each element can change, what are the different ways by which it can change. So you have to see like if there are minor or there are major variable or factor associated with a particular element. So it is possible like switch on always takes by and large similar kind of the time every time, so there is no major factor. Only all other factors are like the height of the person or the kind of the fatigue of the operator, the temperature, humidity affecting the alertness of the operator, but all those are the minor factors and there is no major factor that can affect the switch on or switch off time of the machine. Okay, so whatever the factor or the element for which the time is to be seen has to be analyzed to see if it has certain minor elements or the major factors or the minor factors that can affect the time to complete the job. Okay, so just for example, like say that I gave example last time, like the time for walking or covering a certain distance. Okay, time to move the things from one location to another, it will depend upon obviously certain minor factors and certain major factors. Okay, so what can be the minor factors? Like height of the worker, certainly this is a minor factor. Then there is a temperature condition in which the worker has to do the job, humidity, okay, lighting. So all these are the minor factors, may not be affecting the time very significantly, but on the other hand the time to cover time to move the things from one location to another will significantly depend upon the distance to be covered, or if if there is a significant variation in the kind of the resistance or the load which is to be handled, then the load may also be another variable. Okay, so in that case we may have a plot like this: distance in the x-axis and the time on y-axis, and we will find when worker is lightly loaded he takes very less time, like say L1, and when he is heavily loaded he takes longer time, L2. So we may have the different factors that can affect the time. Similarly in case of the machining time, okay, in case of machining time there can be lot of very minor factors, like it is possible like machine condition is not that good, okay, or the tool condition is not that good, or like say there can be minor property variation in the material, minor property variation of the workpiece material. So these can have very minor effect on the time a job will take or time to machine a job that will take. On the other hand, the machining time may be affected significantly with the length of the job to be machined, the diameter of the hole to be drilled, or the area of the job to be finished, like in grinding or in surface grinding. So there can be certain major factors that are affecting the time, and there can be certain minor factors, and the relationship of all these major factors on the time must be established using suitable approach. Okay, so the time versus the major factor or characteristic or property relationship has to be established. It may be graphical like this, or it can be analytical like what we talked yesterday, like the time for setup. There was one example, yes, yesterday we saw one example where there was like the T1, then there was a time difference of T2 minus T1 into F. So F was like relative thickness for given width and the varying thickness case. That's what we talked yesterday. So here this is the analytical method, this is the graphical approach. Likewise the other things or other possibilities are like, let's have the regression analysis. So we have some kind of the equation showing the dependence of the time on other variables or the factors affecting the time to complete the job. So regression analysis showing the relationship between the time, some constant, then some variables, a constant and the variable x, then constant variable y, then constant variable z. Like this kind of the equations can be developed. So whenever the new job comes in, say just for example, you have got the time for a particular regression equation for machining a particular job. Okay, let's say it is about the diameter of the hole which is to be drilled and the length of the hole which is to be drilled. These are the two main variables, say major factors which are affecting. So what will have, some constant plus another constant will into the length plus the diameter, another constant, and the diameter of the hole to be drilled. So the moment we get the value of these coefficients, then the job, that new job for which the length is new or the diameter is new, once that is known, or means if a new hole of the different diameter d or length is to be drilled or produced, we can predict, we can calculate the time to complete the altogether the new job or the job of the different dimensions, of course within the range of that study. Okay, so the regression analysis is there are different ways. So here I will be talking about the regression analysis which is done using the Excel sheet. There are various analytical methods to develop such kind of the equations. So how to do this using the Microsoft Excel, that about that I will be talking now. So here, say just for an example, how do we do and how do we move ahead? Okay, so let's say what we do basically, first of all we try to get the time values for the different factors, different major characteristic parameters, say the time versus the different characteristics. This kind of the time is obtained, and then a scatter plot of this between the time versus, so this is obtained from the database, and then scatter plot of time versus that characteristic is plotted. Okay, so this plot is developed. This will give idea of the kind of the relationship which exists. It is positive, negative, linear or curvilinear, like that. Okay, thereafter we perform the regression analysis to see what is the degree of dependence of the certain characteristics, what is the kind of relationship, and what is the extent of correlation between the time and that characteristic. So that is what we get from the regression and analysis. Okay, so time versus characteristic relationship in form of equation is realized. Okay, so and that will be giving us the time to machine or time to complete that particular element when the job of the newer characteristics is to be produced. Okay, so now we'll take this, I'll go through this PPT. So here say there is a washer manufacturing company washer manufacturing company is manufacturing the washers of the different diameters. Okay, so these are the various models of the washers. And how these models are different? These models are different with regard to the internal diameter, ID. Okay, with regard to the internal diameter. Okay, so and this axis shows the number of hours required to produce 1000 washers, and all these washers are made of the same metal. Okay, same metal and same thickness. Same thickness, right? So same thickness and same diameter. What is the difference? Same thickness and the same metal, but they are different in terms of the internal diameter. So internal diameter, this is one element that drilling a hole to produce the washers, and so the diameter, internal diameter, is a kind of the major factor or major variable or characteristic affecting the time to produce the washers. Okay, so here the time versus the ID internal diameter is the major variable that is affecting the time to produce. So how significant that relationship, and what if the washer of some other diameter is to be produced? Say that washer is of some other, just 0.6 only. So how to get the time for the washer of some other internal diameter? That is what will be identified, and how that is done. So first, using this data, develop the scatter plot. Scatter plot time, machining time versus the internal diameter. So scatter plot is showing some kind of the increasing trend and almost the linear relationship. So what is the kind of relationship and how easily we can develop the time to machine any washer of any other diameter in this range from 0.06 to 0.87. Okay, so in this range, if any other washer of any other diameter is to be made, how to get the time value for that? So for this purpose, these are the steps. Like first, the time here is dependent variable. So the time here is dependent variable, and the ID or internal diameter is the independent variable. This ID is the independent variable. Okay, then develop the scatter plot, and here what it suggests that there is almost linear relationship. So we will try to do the regression analysis to see how the time is changing as a function of the internal diameter. So that data value is entered here. So for the different models having the different IDs, the data is entered. Okay, and this is about the time for manufacturing 1000 values. So what we do basically here, in this is the Excel. Okay, you can see this is the Excel sheet, Microsoft Excel, right? And so what we'll be doing after entering this data, we'll select the data. Okay, and when we click on the data, we get the this data analysis option. So the moment we click the data analysis option, it gives us the various options related with the data analysis, and here we select the regression. Okay. So obviously after selecting this, we'll click it on click. Okay. So here when we select, although it is showing directly, so here when we select, it will be asking for the various options. I will show how it asks. So it will be asking for various options. What is the y variable, what is the y parameter and its range. So we'll be writing, say the y here is of our interest is the time. Okay. And x here is the id. So id is that is the independent variable and time is the dependent variable. So id will be on the x axis and on the y axis the time is selected, okay, for the analysis purpose. And then when the analysis is done, what we get, that if the r square values and adjusted r square values, if these are close to 1 or as high as close to 1, it suggests that this kind of the analysis is perfectly representing to the situation for showing the relationship between the machining time and the internal diameter as far as this analysis is concerned. This is one thing. Second is if the value of this f, if it is less than 0.05, then it will indicate that the parameter effect is significant. This id effect on the time is significant. Okay, so the value of this f should be less than 0.05. Okay, and it further gives us the intercept of 0.57 and the slope of the equation, a slope of that line is 0.52. So from this what we get, y is equal to mx plus c. In this equation, c is your intercept, so 0.57 plus 0.52 into the id. This is the x variable. So this is the kind of relationship that we get for y is the time here, or the machining time. So machining time can be obtained for any other diameter in the range which has been studied using this kind of relationship. Okay, in this case the only variable is the id, but there can be a situation where there are number of other variables like this. Here the time for cutting, this example I gave yesterday also, like the sheet of the different thicknesses is to be cut. Okay, like 1, 2, 3, 4, these are the different thicknesses of the sheet which is to be cut, and the width of cut is say from 6, 12 to 20. All right. So and the time values for cutting the different widths and different thicknesses is given here. So what it shows, there are two major variables that are affecting the time. One is width and another is thickness. Okay, so both are the significant variables. So we'll be trying to see the relationship here. This is just a scatter plot for different widths, say for 6 as a function of thickness, for 6-inch width, for 16-inch width, for 12-inch width, for 20-inch width. Okay, so in all these cases what we see, there is a positive trend and almost linear trend as evident from the scatter diagram. Again we enter the data in the tables, like say width is 6, 12, 16 and 20, and for different thicknesses how much time it is taking, that is mentioned in this time table. Okay, so there are two, if you see, there are two variables, t is that is thickness and w that is width. Both are affecting the time significantly. So this is how actually it is selected. So we select first y parameter, y. So y is the our dependent variable time. It's selected. So we select the rows from this to through this entire range up to this, that will be included in analysis. So input for the y range. Okay, now similarly input for x range will be given. So x here there are two, so we can select all these. Okay, we can select all these values in order to do the kind of analysis that we want. Okay, so both is columns can be selected in one go. Now thereafter the regression analysis is done. What it is showing, it is, although like adjusted R square is not as high as it was there in the last time, but still it is showing some kind of the relationship, and it will see if the thickness and the width are the significant variables that will be indicated from here. So this indicates significance. F indicates that smaller is the better, less than 0.06 is usually the significant, so it is actually less than the 0.0, it is 0.05, less than 0.05, and then it will be giving us further the value of intercept, a coefficient for width and coefficient for thickness. So we get the equation here, the time for cutting the sheet of the different widths and thicknesses can be obtained using this, like this is the coefficient associated with the width, and this is the coefficient associated with the thickness. So the moment we have to cut the width and thickness of some other values for which the data is not available, by putting those in this equation we can calculate the time it will take. Okay, so now I'll show you just one example. So I need to exit from this, like how it can be done actually. So here I have Excel sheet, say, so this is the Excel sheet, this was done by me only. So here you see this is the width, say 12, 14, 18. Okay, 12, 14, 18, 3 widths were taken, and the thickness is changing from 2, 4, 6, 8 and 10. So again the same thickness for 14 width and for 18 widths. Okay, and this is the corresponding, just for example, the time values it is taking to manufacture or to produce. Okay, so what is happening when we do the analysis? How do we do the analysis? Let me show you. So what we'll do, this is the data and this is the data analysis. Okay, so the regression is, say here it is selected like this, right? Okay, so now input range, y range is to be given, then we'll select from here, okay, to this entire y value will be selected. This will be the, like the C from 4 row to the, C is the column, 4th row to the 18th row. Similarly, now the variable, you can select one by one or you can select that differently also. Like if in this case both are affecting, so we will select both. Okay, so you can have just effect of this also, thickness only, like this. So it is just like the B thickness effect on the time will be shown. Okay, like this. So now we do the analysis and it gives us the equation like this. Coefficient here is minus 21.9 and the variable coefficient, like say the thickness coefficient is 53. So here our equation for the time, so the T, machining time or the time to cut, is like say minus 21.933 plus 53.36, say this is thickness. So this is just the thickness relationship. Similarly, now what we can do, go to the again say the same data, and for data analysis like this, regression. So this is the time value is same, and but the this will change if you have to do the analysis for width. If you want to do analysis of both, then it can be selected like this. Okay, it will give us like A4 to B80. Okay, so here we go. So there are two variables, and the coefficient for each variable is different. Okay, so here for one, for thickness it was 53 na. So here our equation now will be, okay, so our time, machining time, considering both minus 1907 plus 0.3 0.23 plus then first is 12854 width, okay, plus 53.36 T. So if the width and thickness both are changing, by putting these values we can, so this coefficient basically indicates the relative effect of the variable on the time. Higher the coefficient value, greater is the you can say, here it is 36, so greater is the effect of that parameter on the now it can be positive or it can be negative. If the effect of a particular parameter is negative, then this coefficient sign will be negative, or if it is positive, then if the effect is positive, means like the parameter is having the positive negative trend or positive trend on the time. Accordingly, the value will be positive for this case and it will be negative for this case. Okay, so this is how the analysis is done. I will give another example here. That is this case, like say I was talking about, like in the standard data method we develop the codes also. When the number of activities with the different dimensions and the different diameter, different parameters, if the time is to be obtained, then how do we do? Say for one particular kind of the operation, elemental code is 10 to insert the material. Okay, elemental code is 10 to insert the material or hold the material on the machine. Then 20 is align the material, then drill the hole, so then cut the job to the desired length, then finish the job and then remove it. Okay, remove the material. So if you see the insert the material, align the material and the remove the material, if you see these three, these are not dependent on the minor variation or the type of the material or the characteristics of the job, but if the whole depth and the whole length, diameter, the length of the job or the dimensions of the job which is to be cut in, or the surface finish, that is will be affected by the area to be machined. So now in a company, for these elements, there are different models of a particular job, a particular product, like this, and these elements are repeated in all these models. So elements are same, like insert the material, align the material, drill the hole. Okay, then there was what it was, say 40 was cut to the length, finish the surface, cut to the length, finish the surface, and then remove the material. So if you see the time for these three, 10, 20 and 60, okay, it is almost constant for the different models, right? So it is not changing in any way for the different models, almost constant. Similarly for this 38.38, 0.35, 0.35, 0.37, likewise. Similarly for this element also, the time is almost constant irrespective of the model which is being manufactured of particular type of product. Okay, so these elements are, you can say, the constant elements. Means time is not being much affected. On the other hand, the elements like elements like 30, 40 and 50, See, some additional data sets are available related with these, and what it will show, like with the change of model, there is a significant change in the time values from 12.06 to 7.25. Okay, similarly, that some kind of the variation is existed. There is, these are the models, these are not the properties of the job, these are just models. So the time values may be time values are changing significantly, like say 0.275 to say 5.84. so there is a lot of variation. Similarly here, so for these three elements 30, 40 and 50, there is a lot of variation in the time for the different models, suggesting that there is a possibility of a variation in the time with certain characteristics related with the job. So additional data sets are available for these. So this is what I have already said, like these elements appear to be constant, while these elements require more information, as evident from the additional data sets are available for 30, 40 and 50 elements. Okay, so this is the same about which I have talked. So for element 30, the additional data sets are available in form of, like say for different models. Okay, the time is changing significantly with the change of diameter. You can see change of diameter and the change of thickness. So here the thickness is changing and the diameter is changing, and both may have the combined effect on the time that a job is taken. Significant variation is taking place, say from 0.634 to 12.06. so definitely some kind of the time versus d and the t has to be identified, thickness has to be identified. Similarly, for the different models, the time is also shown here, and the dimension, there is a variation in the area of the job which is to be finished depending upon their dimensions, like length and width. So there is a possibility of kind of relationship between the area and the time that is taking. Similarly, cut to the length. So the time to cut length is also changing with the length and the time relationship for the different models. So what we'll be doing, we'll be plotting the scatter diagram for this, and then we'll do the regression analysis. So have the time in y-axis, and for x-axis you select the diameter and the t value, thickness value, for the analysis to see the relationship between the time and the diameter and thickness, relationship between the time and area to be finished. Okay, and the relationship between the time and the length of the job to be cut. Okay, these are the data sets are available. So from these data sets, now develop the regression equation so that we can extract the time for any other job having the little different diameter in the same range for which the studies have been made, or for which the data has been used for the analysis. Say, so for the element when the hole was being drilled, for element 30, the time regression analysis gives us the coefficient 2.6 and the diameter 28.4 into the diameter minus this 5.1 thickness. This is the kind of the regression analysis equation. Similarly, for machine element cut to the length, the regression analysis gives us the relationship like this, and for finishing the job, regression analysis gives us the time to finish the job having the different areas using this equation. Now any new job when is to be produced, so element 20 and 60, these are the constant element. Time is almost constant irrespective of the dimensions, minor variation in the job models. But if the moment we have to manufacture a new job or the newer model, So that will be different in terms of the diameter, thickness, the length, and the area for which the hole is to be drilled, length is to be cut, or area to be finished. So for that, time can be obtained through these computational, through these regression equations, to arrive at the time that the element 30, element 40, and element 50 will take. Okay, so this is the last slide, which will show that time for all 6 elements must be used for compiling the time for the new job. So that time for element like these 10, 20, and 60 are constant regardless of the product characteristics which is being manufactured. This element time for time for element 30 is calculated using the hole diameter and the material thickness to be used, and the element 40 is calculated using the length of the job or the part to be cut, and the element time for element 50 is calculated using the area to be finished. Okay, so this is how the time for all the elements is compiled, and we get the total time, okay, to do a particular job. Once we have, say, setup time, okay, like this, and the time to and the quantity of the job which is to be made into the cycle time for producing the one job. Once this is available, okay, we can get the time to produce a batch of quantity Q. Okay, so this is how we use the standard data method for arriving at the standard time using the macro elements, using the database available from the past history of the time studies, or it can be developed also if it is not available. So standard data systems are also developed so that it can be used for developing the time quickly, easily, which can be used for large number of the purposes. Okay, so that's how we complete this standard data method, and ergonomics chapter probably will start tomorrow.